Okay, guys, I thought I would go through this, the makeup test as a review for your actual test. If you can have a copy of your reference sheet handy, that would be great. And also the unit circle. You could use your project. How nice, right? Because I'm sure you did a great job on it. So anyway, it's super late at night. I'm gonna try my best to not mess up, but I'm super tired, but I want to get this done so you can have it for next week. Okay, so let's take a look at the first 11. You're not supposed to use a calculator. You don't need it anyway. So let's look at the very first one. Which of the following describes the measures of all angles that are coterminal with the angle whose measure is pi over 5 radian? So remember, coterminal just means it would be like a 100-degree angle and a 460-degree angle, right? If you went to 100 degrees and then you did a full circle and then went to 100 degrees, it would look like the same angle. So coterminal angles they differ from each other by a full 360 degrees. We're not talking about degrees here, though. We're talking about radians. So what is 360 degrees in radians? It's 2 pi. So I just want to take pi over 5, and I want to keep adding 2 pi to it, but not just one time, because that's just one circle. What if I did 2 circles or 3 circles or 4 circles? So I want to be able to take 2 pi and multiply it by however many I want, and end up with the right answer. So, oops, that's why the answer to this one is just going to be B. Okay, because I have that pi over 5, and I'm adding 2 pi times whatever, and that will get me all the other ones. Okay, let's try number 2. 2 through 4 is all the same thing. I just have to convert from degrees to radians. So to do that, all you do is take your degrees and you're going to multiply it by pi over 180. And then just simplify that down. So you can always cross off the zeros and then just reduce 22 over 18. That'd be 11 over 9. So it looks like 11 pi over 9, choice C. Okay. 3 is the exact same idea. I'm just going to go ahead and do 345 times pi over 180. And then, let's see, I had done this out before. You could reduce by, that reduces down to be 12, and that's going to reduce to be 23. So I got for number 3 would be 23 pi over 12, which is none of these. Okay, and then 4, same thing, 150 times pi over 180. I can cross off the zeros, reduce by 3, 5 over 6. So 5 pi over 6, choice A. Okay. Now to do the opposite, to go from radian to degrees, you're just going to multiply by the reciprocal. So for number 5, I want to do negative 11 pi over 9. Now instead of multiplying by pi over 180, I do the reverse, 180 over pi. And it's actually kind of easy to remember because in degrees, you're never going to have pi in there. So pi needs to be in the denominator so that these cancel. Okay, so if you're ever like having trouble remembering, well, is it pi over 180 or 180 over pi? That's an easy way to remember it because those pi's need to cancel out when you're going from radians to degrees. And then if you know this one, you know the other one because you would just flip it. Okay, so anyway, I can also reduce the 9 and the 180. 9 goes into 9 once. 9 into 180 would be 20. So negative 11 times 20 is a negative 220. Now you might be tempted to select B, but B is not negative. So, and our answer is, so the only thing we can try is we can find the angle that's coterminal with negative 220. So if we add 360 to negative 220, we get, 140, which is not one of those choices. Oh dear. Sorry, I just dropped everything that I needed. Hang on. Okay. Hopefully I didn't mess anything up. So anyway, I got negative, what was it, 140, which is none of these. So I would choose choice D on 5. Okay, and then 6, same thing. 17 pi over 12 times 180 over pi. Pi's cancel. I can reduce the 12 into 180. 180 divided by 12 is 15. So that's a 15. And then 17 times 15 is 255, choice B. Awesome. Okay. Let's erase all this, and then we'll try the next page. Okay. Next page. Where are you, next page? How do I get to the next page? There we go. Okay, so 7, I'm doing the same thing. I want to do 5 pi over 6 times 180 over pi. Cancel those pi's, 6, 30, that would be 150, choice B. Okay, great. Now 8. This is where you're going to want to have your unit circle out. So if you, also your reference sheet would be helpful. If you take a look at sine of theta on your reference sheet, that's just going to be equal to y divided by r. But remember, in the unit circle, that r is just 1. So sine is really just equal to whatever the y coordinate is. So if you look for 4 pi over 3 on your unit circle, just take a look at what its y value is, and you should get a. So that's as easy as that is. So if you have your unit circle in front of you, awesome. Okay, now number 9 is a little bit trickier. If you look at the reference sheet, you'll see that secant is equal to 1 divided by x. So let's just jot that down. Secant of theta is going to be 1 divided by x. So what you need to do is you need to go to that unit circle. You need to go to 7 pi over 4. You need to look at what its x value is. And then you want to do 1 divided by that. Okay, and I think, I don't have my, I think it's, isn't it root 2 over 2 is the x value. So I want to do 1 divided by root 2 over 2, which really just means keep, change, flip, right? Keep the 1 times and then flip. So now I have 2 over root 2, but I can't leave it like that. So I multiply by root 2 over root 2. So I get 2 root 2 over 2, but then the 2's cancel, and I'm left with just root 2, choice C. Yep, that's right. Okay, and then cotangent. So cotangent on your reference sheet is x divided by y. So let's just jot that down. Cotangent of any angle is just x divided by y. So go ahead and go take a look at 5 pi over 6. And let's see. So I have my unit circle over here. X for 5 pi over 6 is negative root 3 over 2. And I'm going to divide that by y, which is 1/2. So keep, change, flip. I'm going to keep the numerator as it is. I'm going to change it to multiplication. So, oops, negative root 3 over 2. Change to multiplication, flip it to 2 over 1. Cancel out those 2's, and I get negative root 3. So choice C for number 10. Okay, let's erase all this, and then we'll move on to 11. Okay. 11. Give the exact value of W in the interval 0 to pi over 2 such that secant of W equals square root of 2. So again, you're going to look at your unit circle, and we're looking for a value in between 0 and pi over 2. Okay, so that's really in between 0 and 90, right? So I'm looking for someone that has a secant of root 2. So remember how you find secant, if you look on your reference sheet, secant is 1 divided by x. Hang on, okay, so secant of theta is going to be 1 divided by x. So I'm looking for someone that when I take 1 and I divide it by whatever their x value is, it's going to spit out a root 2. So if I look at my choices, for pi over, there's only 3 things in between 0 and pi over 2, right? So if I did 1 divided by root 3 over 2, is that going to get me that? No. So pi over 6 is not the right answer. If I take pi over 4's x value, root 2 over 2, is 1 divided by root 2 over 2, does that spit out root 2? Yes, it does. You just did that in, what was it, 2 problems ago in number 9? So I already know that it's going to be pi over 4 that has a secant of root 2. Okay, you can try the other ones if you want, but no need. Okay, so that's that one. And let's go on to the next page. Oh, jeez. There we go. Okay, so for this one, I want to find the length S in the figure below. So let's see here. And now remember, we can use a calculator. Oh, shoot. I wasn't. Whoops. I use a calculator a lot. I guess you can too. Oh my goodness. All right. Anyway, find the length of S in the figure below. So this is, again, your reference sheet. Look at the back of the second page. That's where all the chapter 3 stuff is. So for this one, you're going to be using S equals R theta. Just remember that theta has to be in radians. Okay, S is the arc length. So if you don't remember, if you literally walked from here to here, that's referred to as arc length. Okay, so if you went for a walk on a circular track and you walked from point A to point B, you would have walked a certain distance, right? So you can talk about that distance in feet, meters, whatever it is, but since you went around a curve, that's why it's called arc length. Okay, so to find it, I just need to do the radius times theta in radians. They did not give me theta in radians. It's in degrees, so I'm going to have to convert it. So you already know how to convert degrees to radians. So let's see, I'll do it over here. 100 degrees, I just multiply by pi over 180. You can cancel out the zeros. 10 becomes a 5. 18 becomes a 9 if I reduce by 2. So I have 5 pi over 9, and I know my radius is 15. So 5 pi over 9. Now, you want to take a look at your answers. A, B, C, and D. None of them have pi in it. So that's a clue to you that you're going to pop this in the calculator and see what it spits out. So most calculators have a pi button. So you can just use the pi button. If yours doesn't, you can go ahead and use the 3.14, but you just have to be careful about rounding. Okay, so if I pop that in my calculator, I get 26.17 blah, 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 blah. So I'm going to round that to 26, choice C. Okay. Now 13 is related to this one. It says, what would the radius of the circle in the figure above, what would be this radius of the circle in the figure above if the arc length doubled and the central angle remained unchanged? Okay, So now we're going to double the arc length. So we just found out the arc length was 26. So well, hold on. I'm still going to use S equals R theta. But now, instead of S being 26, now it's twice as big. So that's going to be 52. So if the arc length were 52, they're asking me to figure out what the radius would be. So I'm going to leave R as it is. And then theta is what it is. It's the 5 pi over 9. That is unchanged, 5 pi over 9. So there's my equation. All I have to do is solve for the radius. So the easiest way for me to do that is to multiply both sides by the reciprocal of 5 pi over 9. So I don't really have enough room to squeeze it in here, but I'm going to multiply everybody. Oh, I guess I could write it this way. By the reciprocal, 9 over 5 pi. So I'll have 9 over 5 pi times 52, and that's going to equal my radius. So I can do all of that in the calculator. One thing I want to caution you on, when you're see how I'm dividing by 5 pi, you need to make sure that you put 5 pi in parentheses. Otherwise, if you do like 9 divided by 5 times pi, it's going to do 9/5 times pi, and that's not what you want. So if you have anything more than just one number in the denominator, you really need to put that in parentheses. And it's funny because as I'm telling you to do that, I'm not doing it on my own calculator, so I better go back and fix that. So I have 9 divided by 5 pi in parentheses and then times a 52. So I get 29.79 blah, blah, blah. So that's going to round to 30. So choice D, and that is correct. Okay, let's erase and move on to 14. Okay. 14, you probably know how to do this from your area of the loom project. Find the area of the sector of the circle intercepted by a central angle of 245 degrees in a circle of radius 9.8. So the formula that you need, again, this is on your reference sheet. Area of a sector is 1/2 r squared theta. Okay, same one we used on our project. Again, theta has to be in radians though. So let's take a minute and convert 245 degrees into radians by multiplying by pi over 180. So, and actually, you know what? Since I'm doing all this in the calculator, I'm not even going to bother to reduce and all that. I'll just let the calculator kind of do it for me. So I'm going to move down here so I have a little bit more room. My area is going to be equal to 1/2. The radius of this thing is 9.8. So I'll do 9.8 squared times this whole thing. I don't really have enough room to write it on here. So I'm going to pop all of that in the calculator. So let's see what comes out. I've got 1/2 times 9.8 squared times 245 pi divided by 180. Okay, I hit enter, I get 205.3, choice B. Okay, 15's nice and easy. Oh, I should have said way back when. You need to make sure that we're in radians. So double check that your calculator is in radians. Mine already is. I've been using it on this step. So for 15, I'm literally hitting sine 0.1298. Hit enter. You should get 0.1294. So that's choice C. If you are using Google as your calculator, or your phone turned sideways turns into a scientific calculator, you can change those to radians. Same thing on just Google as your scientific calculator. There's a little thing on the bottom, you just switch it to radians. Okay, so 15 is an excellent problem to do. Make sure that you are getting the same answer that I am. So if you have it in the wrong mode, you're going to get a totally different answer. So radians, radians, radians. Okay, so for 16, Remember, there is no cosecant button, but it is the reciprocal of sine. So I want to do 1 divided by the sine of 2.7839. And that spits out choice D, 2.8562. Okay, so 16 is choice D. Okay, and 17 is a little bit trickier. So, all right. It says find the value of W in that interval from pi to 3 pi over 2, such that cotangent of W is 0.67542. All right, so this is what's weird. First of all, there's no cotangent button, but it is the reciprocal of tangent. So we're going to start by doing, let me see if I remember how buttons that I pushed. I think I did, we're going to do 1 divided by inverse tan of 6.7542. Yep, and then we need to add to that. Give me 1 second. Let me just make sure that I push the buttons in the right sequence. Yeah, no, sure didn't. Okay, hang on. Maybe I gotta push it this way. Oh yeah, there we go. Okay. Plus. Oh no, wait. I realized my mistake. Remember, it's late and I'm tired. Okay, yeah, all right, got it. So sometimes you just got to enter it in the calculator the right way, otherwise it gets all weird on you. All right, so for this one, I want cotangent. So the only way I can get that is by doing the reciprocal, right? So what I'm going to do is I'm going to hit second tangent, and then I want to do 1 divided by the 6.7542. Okay, so that's going to tell me who has a cotangent of 6.7542. Now, what comes out is 0.146988, blah, 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 which is not one of these choices. So here's what's going on. Remember this. We have this interval. That interval, so remember, that's pi over 3 pi over 2. So if you're looking at the unit circle, right, and we're imagining that the unit circle was broken up into like our quadrants, like the coordinate plane, it's not really, but you had quadrant 1, 2, 3, and 4, right? So if I'm in between pi and 3 pi over 2, it's as though I'm in quadrant 3, right? So I'm not in quadrant 1, and that's where 0.1469 blah blah blah, that's where that is. So what I need to do, this one's very confusing. I especially, you know, I'm not even with you to sort of draw this out and explain it all. So, well, I guess I can kind of draw it here. So imagine your unit circle. Here's pi over 2. Here's pi. Here's 3 pi over 2. Oops, 3 pi over 2. And here's 2 pi or 0 all the way back. So I'm looking for a value over here. Okay, so when I do my inverse tangent to get this, I'm getting the value over here. So I'm getting this one, but that's not what I want. I want to be over here. So if you remember how we kind of used to do that, I want someone whose reference angle is going to be that same angle. So what do I do to get this? I'm basically going to add 180 degrees to it, or add pi. Okay, I know it is very confusing, this one, and hopefully you can like rewind and listen. Well, don't listen to me mess up. Oh gosh. So anyway, hopefully you got your calculator to spit out the 0.1469 blah blah blah. So you're going to take that value and you're going to add pi to it to get yourself in this quadrant. okay, or this part of the unit circle. So remember that pi is just 3.14, right? So that's how I'm getting my final answer is this 3.2885, or I guess it rounds to 6. So it's B in the end, okay? It might be easier if your test is going to be multiple choice also. So you might want to take these 4 answers and work backwards. That might be a little bit easier because I know this is super confusing, especially remotely. Okay, it's confusing in you know, when we're in class, so let alone when we're not. Okay, so let's try number 18. Oh, we're almost done. Except the last ones are like the super hard problems. That's okay. All right, last page. Okay, 18 is actually not bad. So this one here, let's see, what are we doing? What are we doing? We've got find the measure in radians and degrees of the angle beta formed by the accompanying screen, a line passing through the origin, the positive x-axis. Use the displayed values of x and y at the bottom of the screen. So this, you actually know how to do this. It just looks super confusing. So I'm going to draw it. So basically what I did was I'm drawing this triangle right here. I just drew it a little bit bigger. We're trying to find this angle. That's what they're referring to as beta. But same thing as theta or x, or you know, whatever. That's just a variable. Okay, so we want to find the value of that angle. And they gave me that the x value is 6. So x, remember, is your horizontal distance. So this is 6. And then here's my y value, which is 2.483154. Really? They had to give me every single one of those digits? Anyway, so now that you see it drawn like this, hopefully you see, oh yeah, okay, I just do inverse tan, right? Because I have opposite and adjacent. So tangent of B, beta, I think that's beta anyway, opposite over adjacent, 2.483, blah, 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 all over 6. So now I just take my calculator, I hit second tan, all those numbers, divided by 6. And that's going to spit out for me 0.3924. So I have my answer in radians, and then I could just take that and turn it into degrees, but I'm pretty sure that A is going to be right. So if you want to take the time and convert that to degrees and make sure that that's right, you go for it. But this mama is tired. You would think that my kid would be too. I don't even, it's 10:30. He is still awake. He is 3. How? They're supposed to be in bed at like 7. Every other 3-year-old that I've ever heard of in the whole world is in bed super early. Not my kid. Okay. Anyway, 19. All right, so 19's, it's not too bad once you get the hang of it. So, and if you have your reference sheet in front of you, because that's going to be super helpful. So 19 says, find the linear velocity of a point. So that's V on the edge of a wheel rotating 35 times per minute. That's an angular speed. So that's that funny W. And the diameter of the wheel is 38. So of course that's D for diameter, but we never use diameter. We always want the radius. So I'm just going to change that right now to 19 centimeters, and that's our radius. So then what I like to do is I kind of like to jot down over on the side. Okay, V is the thing that I don't know. I'm trying to find it. Funny W, I have it. That's 35 revolutions per 1 minute. And then R, I have it. It's 19 centimeters. So then I go and I look at the reference sheet and I'm like, okay, what equations have a V and W and an R in it? Or if I can't find one that has all 3 of them in it, I try and find like as close as I can, and then maybe I can solve for one of the variables. Anyway, this particular one, I do have it. It's just very conveniently V equals R. W. But here's the kicker. W can't just be any old willy-nilly W. It has to be in radians per unit of time, okay? And that's not what I have. Rotating 35 times is not radians. So I need to, before I even do anything else, I should probably take this 35 revolutions per minute and change it into radians, okay? So let's do that down here. 35 revolutions. I can do the seconds because, yeah, if you look at the answer, see how they want them all in seconds? I can change seconds at the same time. So right now it's 35 revolutions in 1 minute. So let's go ahead and change revolutions to radians. Well, how do you do that? Well, if you do 1 full revolution, right, that's the same thing as rotating 360 degrees. And that's the same thing as 2 pi radians. So 1 revolution is equal to 2 pi radians. Okay, and then let's just go ahead and change the minutes to seconds at the same time. So 1 minute is the same thing as 60 seconds. Boop, boop, boop. Okay, so now I can go ahead and kind of crunch these numbers. Just let's make sure that all of our units cancel out. So let me just switch colors real quick. Revolutions with revolutions, minutes cancel with minutes, and I'll be in radians per second, which is what I need to be before I continue. So when I do this math, let's see, I have my calculator here. That's going to be 35 times 2 pi, and I want to divide it by 60. Gets me 3.665. So now my values, V equals R W. The radius was 19, and I just found out that W was 3.665. Okay, so let's do that multiplication. And I get, that's going to round to 70 centimeters per second. So that's how you do that one. Okay, so be very careful. That's where you're going to make a mistake if you make one, probably. You can't leave it in revolutions per minute. And it actually says it right on your reference sheet. It says that it has to be in radians per unit of time. So there's a reminder. Got to get out of revolutions per whatever. All right, now let's try 20. 20 can be super confusing until you realize one thing about it, and then it kind of makes sense, I hope. So first, let me kind of try and sketch what is even going on. So 20 says 2 pulleys of radius 6 and 10 are connected by a belt. So let's draw this. I have a little wheel that has a radius of 6, and then I have a bigger wheel that has a radius of 10. And then what's going on is, hold on, let's get all my colors here. Let's try this. Okay, now you have this belt that's going around these two. And the 2 wheels are spinning and the belt is moving. Okay, so can you imagine this? Can you imagine that this belt is spinning and it's making the 2 pulleys spin? Or I don't know which one's doing, maybe the wheels are turning and it's making the belt spin, or vice versa. Doesn't matter. Everything's moving. The wheels are turning, the belt is moving. Here's the thing that you have to realize about the belt. If I were to measure the speed of the belt, say right here at this point, if I had a little speedometer and I shot it at the belt right here, it's going to spit out a value. Okay, whatever it is. If I took that same speedometer and I came over here and I measured its speed, it's going to be the same. It's the same gosh darn belt. It's spinning around no matter where. If you can pick any point on the belt, it doesn't matter. If you shine a speedometer at it, right, and just take an instantaneous speed of it, no matter where you are, while this whole thing is moving, that belt is moving at the same speed. If it's not, the belt's going to get all bunched up and it's eventually going to break, right? So it's moving at the same speed, the same linear speed, v. So v is the same for this pulley as it is for this pulley. The linear speed is the same. Now, the smaller wheel has to spin a lot faster, right? Because it has a smaller radius. The bigger wheel is not going to spin quite as fast, but that's angular velocity. That's different, or angular speed, right? So the angular speed is different, but their linear speed is the same because they're connected by the same belt. Okay, so I hope that that makes sense. And I'm actually going to erase all this. Well, I'm going to erase some of this extra stuff that I don't really need. Okay, well, let's try that. So, how do we do this? Let's see, it tells us the larger pulley rotates 40 times per minute. So that's actually giving me, for the big wheel, okay, so for the big wheel, I know that its angular speed is 40 revolutions. Hold on, I need more space. And let's change this pen's thickness back down to regular. Okay, so its angular speed is 40 revolutions in 1 minute. Okay, but remember, I can't really deal with revolutions. I need to deal with radians. So let's get out of revolutions. So 1 revolution is 2 pi radians. Okay, revolutions cancel out. So that means this thing's funny W is 80 pi radians per minute. Okay, you with me so far? Now, here's where things get weird-ish. So remember how I said the linear velocity for each one is going to be the same. So linear velocity is V equals RW. So for the big wheel, its linear velocity is equal to 10 times its angular velocity, which is 80 pi. Okay, so far so good? So now, if I take a look at the little wheel, his angular velocity is the same, right? So it's going to be, what is that, 800 pi? So let's put a B for the big wheel. It's going to be 800 pi. So when I look at the little wheel, there's little wheel, he's equal to R times funny W. I'm trying to find his funny W, his angular speed. I don't know what that is. I do know what this is though, because it's the same as that one. They're moving at the same speed. So I'm just going to pop in an 800 pi for that, equal to RW. Oh, but I know what R is, it's 6. So let me change that to a 6. And now all I have to do is divide both sides by 6. And I should get there. Oh, and actually, I didn't even have to do all this extra math because they asked for the angular velocity of each one, and I knew the angular velocity of the big one a long time ago. So the big one, his angular velocity is down here. So 80 pi. So again, if you look at the answers, none of them have pi in it. So I'm just going to go ahead and use my pi button. 80 pi is 251. So I already know my answer's got to be B, but let's go ahead and check that this one over here really is 419. So if I do 800 pi, and then I divide it by 6, yes, 419. Okay, so this problem is kind of confusing until you make that realization that the linear speed for either circle or pulley, what the heck ever they are, that's got to be the same. Okay, so then you could just find it for one, set it equal to the other one, and then solve for the angular speed there. Okay, so Hope this was helpful. Have a good night. I'm going to bed.